Hello everybody and welcome back. Today we're going to be covering writing and appending files in Java. So we've already covered a lot of string methods and manipulation of strings. We've also covered opening files and reading from them, and now we're moving on to the other side of that, which is going to be the actual writing to files. Now we're going to cover things like PrintWriter, FileWriter, and BufferedWriter, and we're going to learn the differences between things like overwriting and appending, as well as how buffering improves our performance. However, it can cause problems for us, like forgetting to close or flush our writer at the end, and how we could end up making some pretty hard to track down mistakes with that. So let's get started with just a basic demo. Let's do a write demo. Now I have no code yet written up, as I often come here with, so this will just take a second. Store it in this folder. Perfect. All right. So similar to when we were doing our FileWriter, or pardon me, our file reader, we have some import statements that we need to bring in, and we could bring in specifically our exceptions and our PrintWriter, or we can once again just bring in that entire IO package, not the specific classes, and that will also be sufficient. If you are curious about the different ways to write your try catches, you can watch the previous video where I showed try with resources and try catch, or you can watch the next video with tries and catches and finalies, and where I talk a lot more about that structure. But just for this video, I'm going to be actually focusing in on using try with resources, with the exception of when I'm showing what happens when you don't use it properly, I guess. So let's just start with try with resources. Now we're going to use a PrintWriter. So that's a built-in Java class. PrintWriter is going to be a new PrintWriter. And just like the file readers and the buffered readers and the scanners, we can pass in here or I guess not the scanner, but the file. We can pass in the name of the file that we want to open. If this file does not exist, it will create it. So we can just say output.txt, even though in this folder, as you can see on the left-hand side here, this doesn't exist yet. That's okay. My code is going to create it. So we can do our try. We can add our catch here, IO exception, and we can print our stack trace out, print stack trace, should anything go wrong. Last reminder, my next video is all about that try-catch structure. So if you're still not sure what that means, you can still just write it because I'm telling you to, and we will focus in on it hard in the next video. All right, so now we have our PrintWriter created. This is going to allow us access to that output.txt file, and we actually use it just as you would system.out.println. Now we'll just say pw.println. And this will put whatever text we put in here onto its own line. And we can do this as many times as we want. Println, writing to a file is awesome. And one more for good measure. Last line of the file. All right, now because we're using a try with resources, this will automatically close the PrintWriter. Again, we'll talk about that a little bit more in a bit, and then we can, finish off our program, finished successfully. Now let's watch what happens when we actually run this code. So I'm going to go ahead and pull this open. We can see my write demo file, is right there. I can compile it into a class file. You can see the class file right there. And then I can run it. And what we'll see is when I run it, the only thing that printed out here is finished successfully. We didn't actually print out any of these words. But if we go up here to that left-hand side again where it says folders 1020 and I click it, we see it did create a file here, output.txt. When I click it, all the lines of the file are in here. Now, if I go ahead and make some changes, hello, Earth World. Writing to a file is fun. Final line of the file. And I'll close this. Whoops, wrong button. Close this up. I will recompile and I will rerun. It finished successfully. The question we're asking ourselves now for just a second is, did it overwrite what was in there? Did it make a new output file? Did it append what was in there? Well, we can see that no additional output file was created here, so it must have done something to the output.txt, and when we click it, we see it did a full overwrite. So if the file exists, it just writes right over it. So even if you're like testing stuff out and putting it into a file, you don't have to always clear out the text file. You can just keep reusing it and it will just overwrite whatever was there. That's potentially what you want and very helpful. Okay, now if instead we wanted to, instead of overwrite, actually append to the file. So we have our current existing file and we now want to append to it. We're going to have to do something a little bit different. Now, similar to how we were doing file readers before, we did a buffered reader and then we passed into the buffered reader not a string of a file name directly, but we had passed in a file reader right into these brackets, and then the file reader is what actually had that string like file name. We can do something similar here, and in fact we have to if we're going to do some appending. So we'll pass in a FileWriter object, and now there we go. By default, this is going to work just as it did before. Instead of hello earth world, let's just make this world so I can just prove that this is still going to work. We go to output.txt, the word earth is gone, but the fun is there and the final is there just as, whoops, that was weird. Picked that file up, but didn't mean to. There we go. Just as we have here, it printed it directly to it. So having the FileWriter in here works just as it did with like a buffered reader file reader. We can do a PrintWriter and a FileWriter. Now this is very important because in order to override the default behavior of overwriting whatever exists on the file, if it already exists, we have to do it actually through the FileWriter. Now PrintWriter has lots of overloaded constructors. It can take in a string directly, and then internally it turns it into an internal FileWriter object and uses it accordingly. If we wanted to be able to change this FileWriter so that we can actually use it for our own purposes like appending, we can actually add another argument right here. So there's a different constructor for FileWriters that takes in more than just a string. It takes in the string and the Boolean. And this Boolean tells us whether or not we want to append to the file. Let's take a look at the Oracle documentation so I can show you exactly what I'm talking about. Here is the Java Oracle documentation for the PrintWriter class. And if we come down to the constructor right over here, we'll see that there's lots of different options for constructors, including a file name directly. That's when we pass it the string right away, or some type of writer, which we have right here. This is the one that we're using when we use a FileWriter. Now, if we look at the FileWriter class right over here, we can see that this can take in just a file directly, just a string name directly, or it can take it in with this Boolean append. So it will construct a FileWriter object given a file name with a Boolean indicating whether or not to append the data that is written. So what this means is now when I run this with this extra condition right here, this extra parameter of true, and I rerun my code, I'll compile, I'll rerun, it finished successfully, I will now have appended to the file, and we can see that the words have appended and continued. This becomes especially helpful if we want to like pretend that this text file was save game data, because we are doing some kind of game, and we want to be able to load from memory, but we also want to be able to save back to memory and keep track of different, save states in our game, stuff like that. So it's good to be able to both overwrite and append to our files. All right, so in our last video, we did talk about the different options when we are reading from files, like FileReader and buffered readers, and even just using scanner directly. In the previous video, we discussed things like strings and string builder and efficiency. We're going to combine those ideas and discuss it again. Here we're talking about PrintWriter, but we also have access to something known as BufferedWriter. BufferedWriter, and we can go ahead and change this to BufferedWriter, just like that. Now, BufferedWriter uses writes and new lines a little bit differently. We can say write. We can do all of these as writes. We can do a new line like this. If we go and check at the Java Oracle documentation for BufferedWriter, you'll see all the methods that you have access to. And this does something similar where it will run and Java, where is it? Write demo, finished successfully. We go to our output and it appended to there as well. We can see we've got writing to a hello world, writing to a file is fun, final line of the file. Now, of course, this is slightly different because each write is not on its own line. We can see that we were able to take that away. And there are ways to make that work as well. It really just depends which of these you're using. Now, how is it that we're going to decide what to use? Well, within this course, it actually doesn't matter. Both PrintWriter and BufferedWriter will perform approximately the same, regardless of which one you're choosing to use in this course. However, there is an internal difference, and as our writing needs grow, we do see a performance difference between these two different types of classes. I have this example already ready to go over here, just because it did involve a little bit of extra writing. I'll go ahead and show it to you. It's very similar to the string builder example. Here we're going to write out 100 million lines of into a file. That's like a lot of lines. Here's our BufferedWriter. We start our timer, we make our new BufferedWriter, we write a bunch of lines out, and then we catch it if anything goes wrong. We can then go ahead and stop our timer and figure out how long it took. BufferedWriter time, T2 minus T1 milliseconds. Perfect. Then we have this optional comparison. We have this unbuffered comparison here. Now, it is machine dependent, but I have found a number large enough that this will sort of show what I'm talking about for this. We have the exact same code again with this T3, T4, and now we're using a FileWriter. This one is unbuffered. Let's take a look at what happens. I'll go ahead and pull this up, clear all this. I will compile all my Java files, and this time we'll run the BufferedWriter demo. Now, it is a little bit longer because it is 100 million lines, but we can see that this BufferedWriter time finished in about 3,900 milliseconds, long, but really not terrible. And then in a moment, we will see what the FileWriter did. There it is. It took about 11,000 milliseconds. So there is a difference as our needs sort of increase. The main difference is that a buffered I/O system, such as BufferedWriter, will be processing the writes to file in sort of smaller batches. You can kind of think of it like bringing in your groceries in shopping bags or bringing in your groceries item by item. So a BufferedWriter is going to allow you to put a bunch of items into a bag and then it ships it off into your home. It puts all those groceries into a bag and takes it into your home. And that is very helpful because it allows you to sort of batch things together. Walking to your house can take a really long time, even if it's just from your car, from the bus, whatever it might be for you. Whereas the FileWriter is more like taking each item individually from your car or even from the store and then putting it in your home. And we can see why that might take longer. Now, if it's only one or two items, or you don't live very far away, or you're a very fast walker, maybe the time comparison is pretty small. But of course, we can understand with that analogy why buffering would be better. We can batch all of our items together and take them with fewer disk operations, making it a little bit faster. The last thing I would like to show off is one of our common pitfalls. Now, one of the most common pitfalls is, of course, us forgetting to close or flush our writers. Now, we talked about closing our files off at the end of the previous video when we discussed file reading, and that holds true for the exact same reasons here with file writing. However, we also now have this understanding of buffering and PrintWriter. You can see we used FileWriter. PrintWriter also does some form of buffering, even though it's not called BufferedWriter. And this, as we just saw, does help us. However, what that's doing is it's basically what's called flushing the buffer to the file every, couple of seconds, couple of milliseconds, couple of minutes. It really just depends. And we saw how that would help us if we forget to close our writer at the end of our program or our program ends abruptly. It's entirely possible for our file to not have all the words that we tried to put in it into it. So I have one more example I'd like to show here. I just have it over here in a slightly different spot. I'm going to move it so that it's all in the same spot over here. I called this not closing child.java. Now there's going to be a lot of code in this example that just won't mean a lot to you, and I kind of had to do that to force Java to actually show off what the issue is. Now, like I said, when we use try with resources, we don't need to put these 2 lines in. But if we're using a try catch, we do need them. This makes sure that anything left over in the buffer after the 1,000 lines in this scenario have been processed get written to the file, and then the close is what actually releases the file resource so that other parts of the program or your system can access them. Now, if we don't have those, you hope that, your computer and Java and garbage collection are going to take care of these scenarios, but I have sort of contrived a situation here that will show what happens using this line right here, .halt, when we don't get that opportunity to ensure that the flush occurs. So let's take a look at this code here. In this code, we have our PrintWriter, flaky.txt. Here we have that, and this is a try catch. So let's put those lines back in for a minute. We're going to write 1,000 lines of code. It starts at line 1, it goes up to 1,000. Let's print every single line into our PrintWriter. Let's flush it and let's close it. So let's go ahead and run this. We're going to do javac k compiled. Let's run it. It's all done running. We can find it right here. And if I scroll all the way down, let me just pick that up. We can see all 1,000 lines did indeed print out. Now let's see what happens without these 2 lines. Remember, these 1,000 lines are being printed in batches, which means it's possible that this is going to be really grim, you guys, I'm so sorry, but as you're walking home from the grocery store with that last bag of groceries, somebody hits you with a car. And you never get your groceries all the way home. Oh no, right? So it's kind of like that idea. That's what this line here is doing. It is basically saying, stop running. We're killing off the process. No matter what you're doing, no matter what's left to do, don't do any of the normal Java things, kill the process. And this is not a line that you should ever really need in your programs ever, but it's here to show off what happens if we try to run this code, and we're carrying that last bag home and we never actually flush our grocery line. We never actually flush our print line. Let's go ahead and recompile with this change. Oh, I didn't save the change, so that's going to be a problem. There we go. We can run it again. Let's go over to our flaky test file and check that out. It only printed to line 922 because we basically said it doesn't matter what's left it to do. Stop doing it. Okay, so we can see why it's really important for us to remember to flush the line before we close out our program. We can see that here. So the things that we've covered include PrintWriter and BufferedWriter, allowing for relatively simple text output and formatting. We talked about FileWriter and how we can actually use that overloaded constructor with the extra Boolean parameter to decide whether or not we're looking to overwrite a file or append a file. We also looked at the performance of BufferedWriter versus a FileWriter directly, as well as one of our common pitfalls of forgetting to flush our line, closing off our resource, and then our file not actually being completely written to. Now, as I had previously said, using try with resources always avoids this issue. But we're going to show that there are more than one option out there. There may be reasons for doing it one way and reasons for doing it a different way. It just depends on what you're trying to accomplish. The last thing that we're going to talk about in our next video is going to be what happens if something goes wrong while reading and writing code. So we've already shown off this catch, but we haven't really talked very much about it. All I've done is told you to make this catch because your code needs it. I've told you what to write here, and I've given you some ideas of what you can put in here. In the next video, we're going to dive a little bit deeper into try-catch structure, what exceptions actually are, how they work, and get a better sense of how we can sort of ensure our code is gracefully failing. Thanks, everyone, and I'll see you in the next video. Bye!